Hi, everybody. Hopefully, you're still with me here. All right, so let's talk about some notes today. All right, today we're going to talk about isotopes. And I'm going to try to be a little short and sweet with this because then we also have to get into radioactivity today as well. So it's kind of a big day for you guys. And I apologize for that. Monday will be shorter, I promise. So, remember talking about Dalton's atomic theory, how he thought that every atom of everything was identical. Well, he was wrong. Atoms of the same element can have different neutrons. He did not know this, okay? And all that would change, would not change any of your drawings at all, except one of those numbers on the inside, okay? And they would have different mass numbers, okay? So what does that mean? It means sometimes we found carbon with 6 protons, which we always did. Sometimes we found carbon with another different carbon also had 6 protons because protons define the element. But sometimes we found carbon with 6 neutrons, and sometimes we found them with 7 neutrons, and sometimes we found them with 8 neutrons. Still made it carbon because you had 6 protons, but changed the neutrons, which changed the mass number. And so that's what an isotope is. Atoms of the same element with different numbers of neutrons. Now, I promise you, I can't go out and tell you this and say, hey, go find me a couple of these different isotopes. You can't do that. You need a mass spectrometer machine to do that. Okay, so we can't do that. All right, so how do we write these symbols and how do you write these things down? Okay, well, it's pretty simple. Okay, what we're going to do is we're going to have our mass number on top. Remember, that's why I was writing the things the one way, and your atomic number on the bottom. Your periodic table flips it and reverses it, and it's okay. All right, it's not a big deal. All right, so sometimes when we start naming them, we talk about carbon 12, which would have 6 protons and 6 neutrons in it. That's why 6 and 6 is 12. Or we have carbon 14, which would have 6 protons and then 8 neutrons. Remember, carbon's always going to have 6 protons in it. And so protons define the atom, okay? All we do with isotopes is we change how many neutrons we have, and that changes the mass number. And again, this is nothing you can do. This is stuff we just discovered in nature already happens. Okay, so it's kind of understand that as well. Okay, so here's what a symbol would look like. Okay, so if you look up sodium on your periodic table, it's number 11. Now, what you have on your periodic table is that Na is 11, and then 22.990 is like the mass number for what that is. Okay, well, they found this particular isotope, sodium 24. All right, so they would write it that way. Notice there's no decimals here. There's decimals on your periodic table. We'll talk about that in a second. Okay, so let's just find our penny, right? Protons, neutrons, and electrons. 11 protons, 11 electrons, because atoms and isotopes are still neutral. 24 minus 11 gives me 13 neutrons. My atomic number is 11. My mass number is 24, and this would be sodium 24. Okay, that's it. Nothing terribly big, all right, as far as what isotopes are. So again, you could do the same thing with this. This part would be 35. This part would be 35. I would subtract these two for bromine, and I would get 45. And then you understand what that is, okay? It's just the way we write that stuff down. Now, we could reverse it. If your atomic number 34, what element are you? So you look on your periodic table. You go to element 34. It's Se. So that would be my symbol, Se. It is selenium with a mass of 78. 34 protons, 34 electrons, 78 minus 34 would be 43 neutrons. Okay, that's all it is. All right, that's not really big. All right, so where do the decimals come from? We're going to skip kind of ahead of this here. Okay, remember these are chemistry notes, so don't panic about all this kind of stuff. Whoa, sorry, got a lot of stuff here. So what the mass really is the average. Okay, so if you think about these kind of things here, you have 5 rocks, 4 with a mass of 50 grams, 1 with a mass of 60. You would simply add all those things together, all right, and get 260 grams and divide by 5, and you would get your overall average mass. Well, that's exactly what we do with the isotopes. Everything that we have found, we average out, all right, and the excuse me, and the average is what we put on the periodic table. So when you look at carbon, all right, we talked about how carbon can be carbon 12, carbon 13, carbon 14, but that average is 12.011, okay? Averages tell us the average mass of the isotope and all of that other kind of stuff, all right? So if we look, okay, and all these kind of stuff, now we're never going to actually calculate it, so I don't want you to freak out about these kind of things, all right? But what it is it's not a whole number because it's an average, and then all the decimals are placed on the periodic table. But it'll tell you which one it's closest to. For example, like your grades. This is how we figure out your grades. We look at your tests, we look at your quizzes, we look at your labs, we look at your homework, all right? So if you got A's in all your homework and A's in all your lab and A's in all your quizzes and A's in all your tests, I'm being hopeful here, and come in and have one bad day, your whole grade doesn't go down. So when they found carbon, most of carbon is carbon-12. Almost all of it, in fact. Just a little bit is carbon-13, just a little bit is carbon-14, okay? Because of that, most of the average mass is closest to carbon-12, all right? And so we would just simply let carbon-12, the average comes out to 12.011. When we averaged it all together, took all the combination of all those things, most of it was carbon-12. Therefore, it's 12.011 is your average between you add up all the masses. We're never going to calculate this, all right? We're never going to go through and give you samples of these kind of things to do. It's just why there are decimals on your periodic table. Okay, that's the only reason why I'm teaching this to you as far as understanding the numbers on your periodic table today. Okay, the next one we'll get into is about radioactivity, about why these things fall apart, which is another thing. Okay, but that's all I want to talk about for isotopes. That's it. All right, remember there are pairs of atoms with different masses because we found them in nature. They just happen to have different numbers of neutrons. And then we got to average those masses together to get the ones on your periodic table. Continue to round them. Continue to do that. Make it easy on yourself. If you were in like an AP chemistry class, then we would keep all those things in there. All right, but for now, keep rounding them. Okay, and so that's what isotopes